Hey everyone, good afternoon. How are we doing? Oh, we have in chat. We have Justin, Max, Whitson, Veda's good to see you here. Anna, good to see you here. Julia, say hey in the chat. Yakui, good to see you here. Wilton, good to see you here. Reed, good to see you here. Who's all in the chat? I swear we're streaming, right? Kevin, good to see you here. Checking the point. Lindsay, good to see you here. We got everyone here in the chat. We got the live chat going. Matthew, good to see you. Make sure to come in when you get here. Say hi. What's up, Mewbot? He says, "What's up, Max?" He can talk for himself. I'll let him talk right there. Mewbot's always there in the background, checking out those points. Cole, good to see you. Lillian, good to see you here. Make sure to talk. That way, when you get 50 points, Mewbot gives you those points right there. So make sure to talk in the chat. Bylan, good to see you here. Make sure to talk. Mewbot sees you. How many people do we have watching? We do not have 16 people. No way we have 16 people. I'm going to go. I should never look at these numbers. I'm going to go. I should pause this. How many people are currently live? 21? No, I know it's game day. I know it's game day, but it's still a class day. You know what I'm going to do? We have a saying in this class. I don't care. I'm doing that because I want to say something. I totally know it's game day. I know it's game day. I know it's game day. But hashtag show up. Hashtag show up. I know it's game day. I know a lot's going on and the world's on fire. I mean, it's absolutely crazy right here. I want to say a big thank you to everyone who hashtag showed up right here. I know the internet's just going crazy. But the biggest thing, I liken everything we do to this. If you were to watch like this thing is the craziest thing you're ever gonna think. If you were to sit down and say, I'm gonna work out, and you just put on Arnold Schwarzenegger on the TV and he's doing some like side delts and he's like, "Rah! It's horrible Arnold Schwarzenegger impression. Sounds more like Stallone, like Stallone. I don't know. I'm not gonna do impressions. I'm just gonna fail at them miserably. Does it work if you watch someone working out? Are you gonna get stronger watching someone work out? If you watch someone work out, are you gonna get stronger? Just think about this. Think about how this works. Are you gonna get stronger watching someone work out? Oh no, Daniel. We're going to throw out 100 points for Daniel. We're just going crazy today. You're not going to get stronger watching someone work out. If you want to get better at tennis, are you going to get better at tennis watching people play tennis? Well, I mean, maybe you might learn a thing or two. You're not going to get better at tennis by, like, a lot better by watching people play tennis. How are you going to get better at tennis? How are you going to get better working out? How are you going to get better at piano? I'll go grab my keyboard over there, which I should be doing. How are you going to get better at these things? How are you going to get better at these things? How are you going to get better at playing tennis? How are you going to get stronger? How are you going to get better at playing piano? Some Fruity Loops right there. Oh, Shiv's really good at tennis. Ooh. Do the work. We're talking about some practice right here. We have tons and tons. I love it. Business analytics is growing. And you know what we want? We want you to be the best. We want when you go to a company, they say, whoa, you learned this? You know how to do this? And the only way you get good at something is by practicing it time and time again. You'll watch, if you watched the coding night last night, if you watched the practice coding night, I made an error. The last one, my brain overheated on. We're talking about practice right there. Whitson, that's worth 100 points. We're just hashtag showing up for everybody right here today. I'm going crazy on those points. But we're talking about practice. You got to hashtag show up. So hopefully I've inspired you. If you're feeling behind right now, what are you going to do this weekend if you're feeling behind? I want you to take an extra 30 minutes or an extra hour, and I want you to go do this weekend. If you're feeling behind this weekend, you're like, man, I'm just totally lost in this class. I got no idea what's going on. Brian, I'm stuck. My brain. I don't know what I'm doing. I got no idea. What are you going to do this weekend? What are you going to do? I just want you to spend an extra 30 minutes to an hour doing this. I want you to block off 30 minutes to an hour and say, you know what I'm going to do? I'm going to do this. What are you going to do? You're going to practice. You're going to do some data camp. I see right there, data camp. Parker's going to do some data camp. If you're feeling behind, if you're feeling stuck, I know you're like, I'm not going to get a grade for data camp. You can learn so much on data camp. You can learn so much. Data camp, do some practice, watch the activity video exactly, and then pause it and try to do the work. And as soon as you get stuck, this is the best way to use the activity videos. Max earning everyone another 100 points right there, and everyone in the class earning those points. What? Don't cry, don't cry, don't cry. Email me. Don't cry. Don't cry, email me. This is our inspiration, our energy. What we're going to do is we're going to get stuck. We're going to make mistakes. We're going to get questions wrong. And we're then going to work to find the answers. Do you think, who's your favorite sports player? I want to know who your favorite sports player is in the chat. Whether it's LeBron or Jordan or, I don't know, Jordan in baseball. Probably not baseball Jordan. He wasn't the best. Alvin Kamara, what is he a sports person of? What sports ball does he play? Roger Federer? I should not have asked sports ball questions because I don't know sports ball. Roger Federer is soccer, right? Is Roger Federer, Justin Tucker, Federer? People are saying, what sports are these people in? I should ask what sports. I'm getting the notes loaded up right here as we do this. Getting the notes loaded up. Oh, Federer's tennis. Roger Federer's tennis. Come on, Brian. You know that. Federer's tennis. Do you think anyone ever beat Federer at tennis? Do you think anyone ever beat him at tennis? Do you think he ever went out and got totally destroyed by someone in tennis at any point in his life? At any point, did Roger Federer play someone in tennis and just lose miserably to that person and just be like, wow, that was horrible? Diego Lawrence beat him a few times. Nadal beat him for sure. And we're not even talking in people's professional career right here. We're just talking in general that these people have been absolutely beaten. And you know what they do? They work harder. I'm not saying like, oh, you just got to keep working. You're going to learn from these mistakes. Might want to learn who Alvin Kamara is. Okay. It's going to be like first round pick. Tennessee football, we learn from our mistakes, right? It should be up there. It's like, I give my all to Rocky Top today, and I learned from my mistakes. Tennessee football, learn from your mistakes. We should be doing that. I'll go in and give them the motivational speech. I wish. That'd be interesting. I don't know. I've had a few Tennessee football players as my students. What is his name? Is it B-Rad? No, Brandolph. Brian Randolph was one of my students. And also another one, I can see his face right now. I'll have to look him up. But I've had a few Tennessee football players be my students. And Brian Randolph, who played in the NFL for just a little bit, I can't talk about past. Well, let's just say I've been very impressed by some students, not saying who, but I never had Josh Dobbs. Yeah, and there's so many. It takes a lot of intelligence to play football. And I think the hardest thing about being a sports player, especially while you're in university, is you're doing sports and you're doing university. You've got to have two very, very strong components of your life. I mean, sports is more than just a job. It's like, and that'd be really hard to balance. So a lot of I've seen how much they work, and they're up in the morning, like at like 4 or 5 a.m. sometimes doing things. They're coming back after the cafeterias are closed. So shout outs to the Tennessee Vols right there. A lot of work, a lot of hard work to balance a lot going on in their lives. So yeah, being a student athlete, I've never experienced it, but I've seen what they do with what they have to balance. So shout out there to all of our Tennessee athletes, working really hard. And playing some really good sports right there. And hey, if we win tonight, that's awesome. We're going to win, right? So let's win this game. Let's start doing some analytics right here. Let's hop into it. We got our motivation. Take a little bit of time this weekend. If you're stuck, let me know. Remember, it's all about that practice. Let's head into the notes. Okay, so we have the notes up. Today, we are doing for loops. We're going to not go to conditions. It is in these notes, but the whole thing we're learning today is for loops. That's the whole next assignment is for loops. Has anyone looked at the next assignment yet? That's the last time the notes were updated, not too long ago. Has anyone looked at the next assignment yet at all? Has anyone looked at the next assignment at all? Has anyone looked at it at all? We'll see if anyone's looked at it. Who's taking a peek at the next assignment? Like, let me see what the next assignment has on it. Because if you look through the notes right here, I skimmed it, but I hadn't started yet. Started number 1. Well, good news right here. You might want to be interested in surrender index, which calculates how cowardly a... Oh, that's such a cool statistic right there. If you've looked at the next assignment, you will start to see questions in this. Not yet. You will start to see questions in this that look like your assignment. So you're going to get a lot of hints here for the assignment. So when we do this right here, why would we use a for loop? It came up last night. Why would we use a for loop? Anyone got any ideas? Why would you use a for loop? Why would you use a for loop? What's the point of a for loop? What is the point of a for loop? It's to create this. To make repetitive tasks easier, Veda, 20 points right there. You're totally right. To make a repetitive task easier. So we're going to be like, okay, we want to do this again and again and again and again. It's a loop. That's the name of it. It's a for loop. It's going to go for this many times and loop again and 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 again. Now, we can do things like conditional formatting. We don't really get into that in 320. We'll get into it in more in 474. We've got if-then statements. It's just like Excel. And I can show you some of this here in a moment. I'll take a moment after we go into this, and I'll show you some conditionals and some whiles. But 474 goes more into coding. Who attended coding last night and actually coding night last night and saw 474 being like, oh, it's this or this? 474 was just, don't worry, I understand 320 was brand new, but I was really proud that 474 remembered a good bit of it. And today we just had their lecture over this, and we went faster than we're going right here. And they were, yep, Kevin. So you probably saw 474 answering a bunch of questions, being like, oh, that's this, and this works this way. You will not learn this perfectly today. You will not be an expert at for loops. Has anyone used for loops outside of this class? Has anyone right now used a for loop outside of this class? For maybe MATLAB or Python or HTML or any sort of code language you use for loop? Me right there. How valuable are they? How valuable are they? Oh my gosh, congratulations, all these people using for loops. How valuable are they? My life is a for loop. Very. They're essential. Necessary. I like that. Parker right there, and everyone. Parker couldn't have said it better. Essential. Very valuable. Use all the time, exactly. They're super valuable, and you have to understand the syntax for them. You have to understand how to construct them. So we are going to be working on our syntax for doing this inside of R right here, and we've got other things we can do, like user-defined functions, tremendously helpful. We won't be doing that today. It's kind of a preview for other things. This is just a review right here. I'm not going to go through the review because it's what we were doing last week. Does everyone understand right here? What are we merely doing? Because I said I wasn't going to go through it, and I'm going to go through a little bit. This is doing what right here? What is this doing? Just describe to me. I'm going to put it in the chat so you can see it a little bit better. Tell me what that does. That just does what? Like when you think about reading it, it's just going to take 2 and do what? So what does that do right there? Assigns 2 to D. Exactly. It's just going to say 2 save into D. So 2 stores 2 into D. Amazing answers. Everyone, you're following along, you're practicing. You just have to keep repeating these things because I might say something like store 2 into D or assign 2 to the value of D, and you'll just be like, boom, got it. Here we're doing the same thing, but we're taking this equation up here and we're assigning it to y so we can make life a little bit easier. So we just have e raised to y, and that's the equation exp, or the function, exp. So that's everything right here because exp raises e to the value of whatever's in the parentheses. Here we are, another example of saving. All this good stuff, just how to save stuff. You can left arrow, you can right arrow. Just remember we're saving into. So this will save x as x plus 1, and this is really good right here if you want to like increase by a certain amount, which we might do. It'll overwrite what was ever in x. Many examples of operations, just examples for you to see. Case sensitive, I think we all know this, and probably the thing that will drive me the most nuts is this, and this. Now, if you can't tell, what I put in the chat just a second ago is actually I, and L. So you, oh gosh, it drives me absolutely nuts. I can't even see a difference between the next two. Just go ahead and type that in the chat right there. Type IIL. I'll give some 50 points. I just want you to see that you're like, and that's just going to be a mess inside of R. Go ahead and try typing that, and you'll just see, yeah, I did type IIL. So 50 points right there. People checking that out. That's just a mess. Oh my gosh, I don't even know what Kevin typed right there. Kevin typed LLL or IIL, or I can't even tell. Kevin messing with us all right there. But you have to be very careful with your capitalizations, and some things can look very similar. S's and S's are also pretty annoying too, because the capital version of S looks just like the lowercase. So you can run into a lot of issues with upper and lowercase letters that look very similar, or I's and L's. Those are just super annoying, and it happens all the time in code. When I have glasses on, I know Daniel right there, some 20 points. I can't tell the difference either. Yeah, you can zoom in on that. No one's going to know. No one's going to know the difference right there. Recursive assignment right here, just replacing the value right here, overwriting it. Good stuff. Vector assignment. Now here's an important thing right here. We have here the vector D. If at the end of this I were to do D, and this is something we should know, if I were to do D3, what would this return with the last vector we've created right here? D square bracket 3. Go to review questions. This is like your data camp practice right here. It says, what will the following code return? Exactly. Now, and everyone, I'm going to throw some 20 points. Everyone is correct. It is going to return you. You without quotes is like an object you. You with quotes is the string you. So technically, it's going to return for 50 points. What? Technically. Don't worry. I totally agree it's returning you. I totally agree. Daniel's seeing it. It's going to be you with quotes, technically. Don't worry. Like, if this was a test question, I'd totally accept you. I'd be like, yeah, it's returning you. But it's returning the string of you. Does that make sense right here? Because if it's in quotes, it's a character string. So very important to know. And so Daniel definitely earning us the points right there. It is returning you in quotes, which is the string version. I'm throwing another 20 points. Please, what you're doing is perfect. Like I was going to say, like, please keep following along. But no, you're doing this perfectly by answering the questions here. And you're just getting more practice like DataCamp would quiz you. What's really cool is we've got this plot function right here. The plot function is a smart function inside of R that will look at the class of an object. What class is this object? Kind of obvious. What class is this object? It's not class categorical, but I mean, it kind of is. It's not class categorical. What class is this object? Class is how R sees an object. I said I wasn't going to review, and then I am. It's a factor. Can you name any other classes of an object, which is just the way R sees the object? So the class is how R sees an object. R sees this as a factor. So what are some other classes? Which is just how R sees things. Integer, which is basically like a quantitative. Numeric, which is quantitative. Vector is like a like you can have a vector with a class. A vector is a bunch of things put together, and then the vector will have a class. And then string is known as a character, so character string. So in table, I think it has two classes. When you make a table, it is class table, and then a table is a named vector. So a table is a named vector. So the table should probably have like class integer, class numeric, class character on that. You can also have another class. No one's put this one in. What kind of class is Brian putting in the chat right now? So if you notice in the chat right now, I just put a bunch of, and let me throw some 50 points. Everyone following along. That's what we want. You got it. You're doing great. Follow along, practice. What class am I putting in the chat right now? That's a different type of class, which is R will see this differently, these objects right here. It is Boolean. They are Boolean, which means like true falses. Booleans. So I think we got some like Pythons. Woo! Python code, and it is Boolean. It is 100%. So Boolean is just trues and falses. Trues and falses. I'll super do my accent. I just take that accent tile and turn it up. It's kind of categorical. This would be seen in R, and you can always check. Let's go check it. The answer's going to be logical. Oh, Veda right there. Veda earning everyone some points. It is logical. So you can always check this if you're wondering how R sees an object. Just go ahead and make a vector. We were doing this last class also. Just throw some trues and falses in, and then go run the class of the vector, and you can see how R sees it. We could also go here and see that if we make a table of this, we could put the table inside of the class, and I think it has two classes. Oh no, it is class table. I'm throwing some 50 points. Someone said class table. You were very correct. It is class table, which is how R is going to see and manipulate that. A table is a named vector, though, so I could do something even cooler. I could go here and go to unname this. I'm betting I get logical. No, it's an unnamed table. R is very smart. It still knows that that's a table, just an unnamed table, which is going to give me just the numbers. Ooh, really? Wow. Can I do an untable? I could do it as numeric. But that's just some craziness right there. It even knows that that unnamed table is still a table. Good job, R. You're smarter than me. So all this right here is how we can look at the class. Class is very important because it's how R manipulates the object. If we tell it this is a baseball, it'll throw the object, it'll hit the object. If we tell it that this is a basketball, it'll dribble the object. It'll do different things with the object depending on the class we give it. And that's what the plot function does right here. The plot function will do different things depending on the class of the object inside of this right here. And great job. Remember, ask those questions if you have it. Great job, everybody. Let's go check this out. Make sure right here that your plot figures are wide enough. Make sure to give it a categorical variable. All this good stuff. Just some errors. We've got here the levels. What are the levels of stake preference? If I go out and ask people stake preference, what are the levels of stake preference? Levels are just the answer to categorical questions. So whenever you hear levels, you're just talking about a categorical question and the answers that people could possibly give. It's not like rare, 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 medium rare, 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 medium rare. That's not the levels. The levels vector will simply be the possible answers, and they could repeat. So the levels vector. So we can look at the levels of a categorical question, and I'll show an example here. They always say show, don't tell, show, don't tell. I'm using library reg class. Make sure you have it installed. We've talked a few times about installing it. So if you don't have it installed, let me know. If we go here to survey 9, which is data inside of library reg class, and I want to show that again. You can tell that this is data inside of library reg class because it shows up right here. So if I go to the class yeah, why not? Class of class, that's a factor. Factors are just what kinds of variables. This is a what kind of variable. Important to know this instantaneously. This is just a what kind of variable. This is something we should just know like that. This factor object is categorical. Great job, 20 points right there. It's a categorical variable. It's categorical. And you can see it over here also that class is a factor. And now if I go here to levels, we're just going to get this vector down here. And the levels vector is this. Now watch this. Store into the levels vector. We can go right here, FR, JR, junior, senior, let's go SR, and sophomore. And sophomore right there, SPH. Now check this out. When I print out the levels, everything's been recoded. You can recode variables quickly like this. So all I did was overwrite the levels vector right here. What library is that? It's library reg class. Make sure you have install.packages reg class going. So you'll need to have reg class. I'm going to drop both these codes in here for you, Matthew. Matthew, 20 points. Thank you for asking about that. I'm dropping both codes in the chat for you right now. The install.packages reg class and the library reg class, which we'll be using a lot throughout the semester. So I've overwritten all of these, and look, it changed all the answers people gave. So you can quickly recode data inside of R rather than going through and just typing and retyping things or searching and copy pasting. Just recode what the levels are. Do we have to do that for every script RMD just once? Exactly. You will install it just once. So you notice I didn't install it right here. I'm going to comment that out. I didn't install it. I just have to turn on the library, and I already have it on in the background. And these are all the libraries I currently have on. So these are all basically like video games on my computer that are currently running, not literal video games. But does everyone understand right now I have access to all of these different things? I can run things from Caret. I can run things from Plotrix, from Lattice, from Mass. Like Mass has a pretty cool function called fractions. And you can see where it's from by looking right here. It's from the Mass package. And so I could go right here and type the following. And that is a fraction. Ooh, that's a ridiculous one. This is this number right here as a fraction. It'll actually reduce the fraction. So 0.12 as a fraction is 3/25. And that's a function inside of the Mass package. Does that make sense right here? That these packages give you additional things. It's like just a video game you have on your computer that has options for you. And so the Mass package has inside of it the fractions function. And you can look at what's inside of it right here by going to this. And, these are like data frames. Those are all data frames. And here's the functions, and there's the fractions function right here. And you can actually look at how the fraction functions work. There you go. Here's how the fraction functions work. So I've never actually looked at that, but that's how the function works. Does that make sense there, Max, what I'm doing? These are all just video games on my computer, and these are like just things I can use inside the video game. To get any of these, you want to make sure you install it, and then you load it. Won't run anything. Make sure you've loaded the library reg class. Does this make sense here, Nathan? Have you loaded library reg class, and then you've loaded the data? So make sure you've installed this. So you need to first install. This will bring up an install window. I'm going to hit cancel. I don't want to install. So that'll install it. And once you've installed it, you'll run it. And if you see over here that reg class, it's probably somewhere on mine. Here's reg class for me. This is currently loaded up. If you don't see it over here, then it's not currently loaded up. So make sure if you click your global environment, you do see that the package is attached. It's in your global environment. So Nathan says, I might have to look, Nathan. When you run this, it doesn't run anything, does it? It should load the data into the global environment. Make sure it auto-completes. I would use the autocomplete. Like if I type survey 10, I run it and make sure to run the autocomplete. Is it working right now, Nathan? I might have to take a look like on Discord or something if it's not working. These are great little things to know. These are little things that just practice over time. Okay, I might have to take a look later, Nathan. Good job, Nathan. Some 50 points. It's tricky. Yeah, we'll check it out. We'll have to hop on and check that out. And I want to say this. Was it 320 last night? That was really lots of questions. No, it was 474, I think. 474 has asked so many questions on Discord. 320, keep asking those questions. Keep working. Keep helping each other. Tag me when you have questions. It lets me see because sometimes the questions are just like, I'm stuck on 4H. I'm stuck on 4B. But expand upon it. Be like, I can't get this to work, or how can you find this? And then tag me. But there's been lots of help. And yeah, it's been very, very busy. And that's what we want. We want to keep busy. Discord saved me last night. Matthew, that's so awesome. 50 points going out there to Matthew. It's all about helping each other. It's all about asking those questions. Start early, ask those questions. And people have been getting lots of help. Start early, ask questions. Adding a new level. Just got the notes right here. Changing level names. I've kind of showed some of this right here. This is all review. So I'm just going through it a little bit quickly because this is the exact notes we were doing last class. So all you're seeing right here are notes that we've done. And now we're up to the for loops. We won't do while loops in this class. We're just doing for loops. So get ready for some for loops. When it comes to a for loop, the thing we will always write is we will always write the what first. Please do this. A lot of people just skip this step and they say, I'm just going to write my for loop. What will you always write when you write your for loop first? The answer's on the screen. What will you always write first? You will always write this first. You will always write this. You will always write your skeleton. I mean, you like someone who's maybe written a ton of for loops is like, I don't do that. It's good practice to start out to always write your code that will repeat. The skeleton is the inside of a for loop that repeats every time you run the for loop. The for loop, think about what it means. A for loop is going to go over a fixed number of amounts. A for loop is going to go over a fixed number of amounts, while a while loop will go while a condition is true. And we won't do while loops here. We'll do that in 474. But a for loop goes for a fixed number of amounts because it goes for that amount of instances. And a while loop goes while a condition is true. I want to see it in the chat. For loop goes for a certain amount. While loop goes while a condition is true. For loop goes for a certain amount. While loop goes while a condition is true. Those are the key differences between the two. For loop will go for 10 times. That's the fixed amount. We say loop 10 times. So the loop loops 10 times. A while loop will go while a condition is true. For loop goes for a certain fixed amount, go 10 times. While loop goes while a condition is true. Nice job, Matthew, earning some points. Let's go see this example right here. Let's go check it out. So if I were to write a for loop, and we'll talk about how to write this here in a second. Well, let's write that skeleton. Here's my skeleton. Let's go here. Print. Brian is awesome. Okay. That's my skeleton. Brian is awesome. And then we're going to print that. And it really doesn't matter. More on this soon. My for loop. What did my for loop do? Just take a look at that code right there and just tell me what my for loop did right there. So this is a for loop. And we said it would go for a certain amount of times. What did that for loop do? It printed 10 times. Because I asked it to. Now what's interesting. You might say, well, why don't we just put 10 over here? It only went one time now. That's going to be very interesting. Why did it only go one time? If you've worked with for loops, you probably know why it only went one time. We'll figure out more in a moment why that only went one time and why we need to give it a vector for it to go through. More on that in a moment. But that while loop, which we won't cover today, but let's see, just an example. Let's go while 2 equals 2.
Brian, what are you doing? Don't do it. No, an infinite loop. No, it's breaking. Oh no, it's never stopping. What is happening?
Calm down, Mubot. We can just hit the stop button. Why is this running continuously right here? Why is this running continuously? Why did that just endlessly run right there? So a while loop runs while a condition is true. Because 2, Julia right there, perfect answer. 2 is always equal to 2. You are correct. 2 is always equal to 2. So since 2 is always equal to 2, the loop will always run. What's this loop going to do? So this is the condition right here, which we wouldn't write loops like this. It's just good to see the basics. What's this loop going to do? And here's what the condition evaluates to. What is this loop going to do? Not run, not do anything, because the condition is false, so the loop does nothing. The loop never runs. It looks at this condition, it says, oh, that's false, stop. So with this right here, we saw an example of a while loop. Won't run, doesn't fulfill the condition. Exactly. Some people have had practice, and I love that. You have to practice. And you're seeing the syntax for R. So if you've done like Python syntax, Python doesn't use like the brackets and stuff. That absolutely drives me crazy about Python. I hate coding stuff in Python sometimes. So here we see basically the control panel, and this is the skeleton. Let's change print right here to something different. Instead of print Brian is awesome, let's just print I. Now this is where things get a little bit more interesting. Does print work with? Yeah, it does. It does. Good. I was a tiny bit worried. I usually use cat paste. So I was like worried my code was going to break. So with this right here, what does this loop do? Now, this is where you have to understand exactly what's going on, and we are going to cover this more in the notes, but I like this example. When I first started coding for loops, I would code stuff like this just to make sure I got it down. Look at this right here. I is a placeholder. I will go through the vector 1 through 10. So the first time this loop runs, I will have what saved into it. Fulfill, just pretend this is a test question. It says, the first time this loop runs, what goes right here? Julia, you're right. Great job, Julia, 20 points. What is I going to have saved into it the first time I runs? I is going to have 1 saved into it. Now be very careful. I want you to write me the next thing that happens. Be very careful. This is where mistakes happen, especially on the homework assignment. Hint, this is very much like a homework assignment question. What line of code will run next? Be careful. A lot of people get this a little bit wrong. So what will run next? Be careful. This is where the mistake starts to happen, where it's like, oh, it'll do this. Well, kind of. What does the code do next now that 1 has been stored into I? What does the code do next? So if I were to run this right here, and we can see what happens when I run it, what did it do next after 1 has been stored into I? Be very careful. Max, you got it. I think you just hit an extra one right there. But Max is correct. It's printing I. But you know what a lot of people tell me by accident? A lot of people don't tell me that it's printing I. A lot of people say, no, with the extra I, but you are correct, it's printing I, but where do people make the mistake right here? What mistake do people sometimes make when they tell me what this is doing? It is printing I, you are very correct. So it's printing I, but what do people sometimes say? They don't say it's printing I, they say it's printing this, because it is, but it's printing I. I know this is, again, I hope this is not too confusing right here. It is printing I, Justin, you are correct. People will tell me it's printing 1. Well, no, it's not printing 1. It's printing I, but I is 1. Does that make sense? Who gets what I'm saying right here? That, no, it's not printing 1. It's actually printing I, but I is 1, so it is printing 1, but it's printing I, but the reason we get 1 is because I is 1. Does that make sense? It's very nuanced. We're not printing 1. We're using the skeleton because the skeleton won't change. It's printing I, but 1 is saved into I. Yes. That's what like people are like, wait, but I see 1. Well, then what happens next? When the loop starts back again and it loops back up to the top, what does I become next? What does I become next? Who knows what I becomes next? The next time the loop goes up to the top, it goes to the next element of this vector, and I will become what? I will become 2. Wilton, great job, 20 points, exactly. We're going to go right here and we're going to save 2 into I, and then guess what? All it does is print I. Do you see how every time we run this, if we go all the way down here to the last occurrence, every time we run this, all we're doing every time the skeleton runs is printing I. What never changes? Every time the code runs, this stays exactly the same. What never changes? I'm touching it. What never changes? What never, ever, 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 ever changes? I'm sure skeletons change somehow, but what never changes about this code? Every time the code runs, what never changes? The skelly right there. Everyone's saying skelly. I love it. That was, Coop was saying last night, the skelly right there. So Kevin was watching the activity. Coop was like, the skelly. You got the skeleton is never changing, which is print I in this. It just runs print I, the skeleton. He-Man references right there. I'll take some 50 points for some He-Man references. So the skeleton never changes. Never changes. We change what is in the placeholder. And this is the placeholder right here. And every time the code runs, it moves this over 1 position. So what if I were to go here and I were to say, ooh, we could do something really interesting. I don't want to make it too crazy. Please note, what is the only thing, what code would make it so where it becomes multiple I's for like the first I, next I, next I? Ooh. So Max, what do you want to say again? Max, go into a little more detail and I can maybe write that. And I want to point out right here, I'm just writing FOR to get my for loop. This is a snippet. If you ever see me make functions, I will type FUN. We won't do functions. We'll do them in 474. But these are snippets. You can write all that out if you want, but it's much easier to type a few letters and get your snippet, and the snippet will start filling it in. Oh, nested for loops. We could do that really briefly here. Parker, let's look at a nested. What if we went here and went for, give me a moment. There we go. And then we went here, I 1 through 10, J 1 through 10, and we went here to cat paste I comma J, and then we need the character, wait, cat paste right here. We need the new line character. There we go. There is a nested for loop. And take a look at what it did. It went through and did all the iterations of the numbers, and we could change the separation right here. So we could go, and this got a little bit complicated quickly. I'm going to slow it down, but this is a nested for loop right here. And now, there you go. There is a nested for loop right there. Not saving the integer into I. So, okay, let me try to do Max's example, and then we're going to go back to the notes here in a second. Max says, so a code where it prints I in quotes rather than a number, and it increases each time. So a for loop where the output is, then, okay, wait. So you're saying it prints like 1, 1, 1, 1, 1, 1? Are you saying that's what you want right there? So Max, are you saying you want the code to output? Let me get what Max wants, and I'm going to try to code it for them. Are you saying you want 1, and then you want 1, 1, 1? Are you saying this right here? Is this the output you're looking for? A character string output that increases each time right here to make it an additional output. So it goes 1, 1, 1, 1, 1, 1, and every time we get the output print, it'll increase what the length of this is by an additional character. Is that what you want? And then you want it to be a character. Exactly this. Okay, cool. We're going to write this real quick, then we're going to hop back into the notes. Let's see if Brian can take on this challenge. You know what it means? Everybody, you know what it's time for. It is time for a little... Oh, wrong music. Stat to 1 Hacker Man, let's do this. Here we go. Can we Stat to 1 Hacker Man this and make the code we're looking for right here? So the first thing we want is we're going to go right here and we're going to have 1 increase in length by each time. Ooh, Parker might have it already. Parker's going to be... Parker's going to have... hard to type code in chat. I totally agree. Parker's going to Stat to 1 Hacker Man this right here. So we want right here a string character. I'm going to write the skeleton first. We're going to do as.character, change the class of it to this. Okay, we've got a 1 right here. What we want to do, though, is we want to increase the length of it each time. So we want to kind of string concatenate. So each time we do this, we're going to string concatenate, which is something you probably don't know. String concatenate is going to join this. And we're going to right here, string concatenate this to, let's go here, a blank vector. We'll call this x. And there's that. And there's the string concatenate. Let's try this right here to put another one. And let's see if that joined it. Ooh, we're on a roll. So he's into the main freeze. So we're going to go right here to I. We're actually going to use this as just a placeholder, 1 through 10. And we want every time, we're going to print X every time. So we want to go to print X right here. I'm writing the skeleton outside of it, as we should be doing. And we're going to start with X with just the first one right here. Let's print X to start. And then this will just do this right here a whole bunch of times. So now we want to start with it just being the first thing. We haven't increased it every time. So now we need to go to our code where we increase it, where we string concatenate right here and concatenate another one. And I think, no, we're so close. Oh, we need to take what was in X. And that was a little Stat to One Hacker Man right there for you. Good question. Tricky stuff. Can you make your code do this? There might be a reason. Oh, we didn't get the first one. I need to go back to where it has the first. Stat to One Hacker Man failed you. Good question. And now we got the first instance of it where it's just one. There you go. Once again, what did you notice me coding first? I was coding outside my for loop. And then I had my for loop go 10 times. Little things like this are great practice. Ooh. Parker, send me your code afterwards to see how you did it. There's about 100,000 ways to do this question. There's infinite ways because you can just change your syntaxes. So with this right here, this is practice. And challenges like this, while we might not have purpose for doing them, build up. Because in my Price is Right, I use while loops right here to go and give the names of the players. Just one last quick example before we go back to the notes. Notice right here that somebody will input the players into the Price is Right function. So when you input the players into the Price is Right function, which I think, I don't have it running. When you input the players into the Price is Right function, it's going to go through and ask you the names of the players while you have not entered in all the players. So let me say 3 players. So while the number of players is less than the number of players, because it's going through and iterating, I can enter in Brian. And you see we're still in this while loop right here, Darren and Emily. And now it left the while loop because the while loop only ran while my counter right here was less than the number of players I entered in. I entered in 3 players. That's what was stored into players right here. And so this is a function that I wrote for the Price is Right. And then you can make nested. Boom, you got it. Is this making sense right here? Why we would use something like this? Because my while loop right here allows me to go while we have less players than the person has selected, which is what this says. While somebody has less players entered in, I could call this like entries. So while someone has less players entered in than they selected players, it'll keep asking them, what is the name of player? And you see it says player 1, and you can see this right here. What is the name of player 1? What is the player name 2? What is the name of player name 3? And this is using a while loop right here to continuously ask them, how many people do you want to play? And then it just goes through and asks you while. If you change the number of players right here, you will see if we enter in like 2 players, you can just enter in Brian and Darren, and then it'll leave the while loop and it goes into the next portion of the code where it asks you about spinning the wheel. This is the application of what we are doing. These things are used everywhere. And it's these little bits of practice right here, whether it's something small or something big, that's going to get you good at it. Let's head back into the notes. I really like those challenges right there. I love it when you say, can you code this? Because you just got to try something random. So what did we notice right here? For loops are going to allow us to do what? They're going to allow us to save a lot of time. Tons of time can be saved by doing a for loop. We can do this, and we need to know the control structure. So let's take a look at these little bits of control structures right here and see what we have. Notice right here, we have 3 saved into X. And then what do you notice? This code right here that I'm going to highlight in blue looks very whatative. This code in blue looks very, very whatative. This code in blue right there looks very, very whatative. It looks like it basically just repetitive. Great job right there, 20 points. Repetitive. That looks like it could be turned into a skeleton if you ask me, because we're just going to change a little thing about that code. So let's try to figure out how to turn this into a skeleton right here. So if you notice, with this code, and actually I'm going to do it by hand. I like showing the example by hand rather. We're going to take this code right here and turn it into a for loop for you. It is shown on the next slide, but who likes reading slides? Not me. So here we are. Now what you want to do once you have your code and it's working, let's see if the code works. Code works, and this is very much like some of your homework problems. Very much like it. We're going to take this code right here, and this is going to become our skeleton. Now you could even do this. How about we go right here and we put this to I. And we just say I is equal to, I don't know, 1. Well, wait a minute. How could I replace, I'm going to put this in the chat, and I want you to rewrite this with I's. Because you notice this code's going to change. I want you to rewrite this with I's. So try rewriting this right here with I's. Like, would this become an I? Would this become an I? Would this become an I? Maybe an I with something else on it? How would you rewrite this code right here, but with I's, so that it solves for the same thing? Because I is currently 1. So, I mean, if we put I right here, that's 1. It's the same thing. Code's still the same. Code still works the same. I mean, what else? Close. So we're just going to replace where we're going to like make it so that this code works, but with I's instead of having 1s in it. Close, Joshua. 20 points right there. You're on the right track. Oh, wait. Well, you're on the rightest track. So it's still the same code. Close, Justin. You're super close. It's just that this one also here changes. Justin, earning another 20 points. Justin, you're even closer. I do agree that this right here is I plus 1. That's I plus 1. And then we have a little, you see how this changes? You see how this changes? So if we call this I, it needs to, I mean, kind of the answer. Who got the last bit of the answer? You're on the right track. You're on the right track. We're just recoding this right here. Yep, William, you got it. You got it right there. Yours might works, Max. I'm going to do, maybe, I'd have to double check. I'm not sure. Throw another 20 points for everyone participating right there, practicing. And now we've rewritten it. Because guess what? If I is 2, does it make sense that this code would become this if I is 2? If I is 3, this code is going to become this, which is just this code right here. So by putting in I, we can just change what the value of I is and go from I being 1 to I being 2 to I being 3, all the way down to I being 6. Because notice how we're using I for this number, so I goes from 1 to 6. Oh, wait a minute here. Well, why are we doing it like this? Because we've just written our what. Like, that is very clearly a what, because I have a placeholder in there that can change. That is very, very clearly my what now, which I've coded it very well now. I can take this. That's definitely a what. That is a skeleton, Julie, right there. 20 points. You're 100% right. That is definitely a skeleton. So we're going to put that skeleton inside of it. This is the body of the for loop, like the whole, like that's the outside of it. And then we're going to go to the inside of the for loop right here. There's the skeleton. What's a variable? Need your help here, everyone. I've forgotten this. Brian's brain's overloaded like last night. I totally don't know what the answer is. A variable is a what? The variable is a what? It is I, and the variable is a placeholder. It can be literally named anything. Problem is, if you call it anything, you'd have to call this anything. So whatever the variable is a placeholder for what changes in the code. Does that make sense what the variable is? It can be anything. You can name it whatever you want. Julie's totally right there, another 20 points. It's just a placeholder for what changes. It can literally be called anything. Like, literally. Last night we called it like something to store something in or something. I was like, we could call it something to something, whatever we want. And someone's like, something, whatever we want to store into. And I was like, well, you're right. I like to call it I just because it's small. Up here would need to be called I. Now the vector is going to be what this takes on every time it runs. So every time this runs, it'll be the first element of what's in the vector. Then it'll loop back up and become the second element of what's in the vector. Then it'll loop back up and become the third element of what's in the vector. It'll loop back up, fourth element, fifth, sixth, or however long the vector is. It'll go through the length of the vector. So what do we want this to take on while it runs? What do we want this to take on while it runs? Our variables, local variables in the loops, they are in the global environment. They will, yep. And I can show it right here. I'll show it. You can see the I right there. So I can show it by deleting that code. And we just need the vector x to start. That's graphics error. So they are local variables. They will be seen in the global environment. And Julia's totally right. This is going to go through the vector 1 through 6. We see this right here that we want it to go from 1 to 6. And this will be a local variable right here. So great question, Parker, right there. Great questions. I'm throwing 50 points. Julia and Parker, keep the questions coming. You can see right here that I, by the end of the loop, was 6, or I is now 60. So it is doing this like super quick. You know what I could do? I wonder if I could do this. How do I make it stop for a second? I'm thinking like if you can check system time, but there's ways to write delays in here. And I'm like, okay, wait. We'd have to write like I've written a counter before, and I'm like, okay, how do I write that counter again? Because you can check the system time in R. System time, there it is right there. So where's system time? There it is, system time. This will get you the system time right here. And you could literally put right here at the end of this, you could go time, store into time, and then go to system time minus time. That's the function. And nope, time, because we stored that into time. And then you could run this right here and see how long it took. That for loop took 4 thousandths of a second to run. So if we were to watch this, I don't even know if the computer has enough frames per second to catch it. Probably not. But if we could watch this I increasing, it's increasing at, divide that by 60. That's how quickly that, if we could slow down the video or slow down the computer to watch it happening. But that for loop runs, we could make it much longer. And it would increase it. Here we go. This is going to take, that took a little over 1/10 of a second. No, you don't see it increasing. And it's interesting, there's variation in the time it takes. It actually took more time the first time. Ooh, maybe it was because the increase of the vector length. So I think it's because the vector is, we had to increase the vector length. I didn't know that. Yeah, that seems to be what it is. It still takes more time the first time. Interesting. It's kind of seeing how R works. If it has to create spots and vectors that didn't exist, it takes longer. And why do we have an extra element right there? I don't know. Randomness. So pretty interesting stuff right here. I like, oh, because we're doing past that last element. Yeah, makes sense. So if you notice, we can make this vector in less than 1/100th of a second. Doesn't really matter how long it is. Memory allocation, exactly. Because I guess it's going to the memory and that it takes even longer. It's already got the memory allocated right now, Parker. So this gets into a little bit of computer science right here with it's already allocated that memory. And if it has to first do the allocation of the memory, then that takes a tiny bit longer, not really longer. But this is where you get into a little bit of the computer science of it, but we don't have to worry about that so much. So it's really good stuff, though. It's really good. Like that's some computer science right there. I'm sure a computer science major could be like, Brian, this is exactly why this is happening. But Parker, 50 points, pretty much explaining with the memory allocation, which we have to do at the start of it. So we're doing all these to save time. It makes life way easier. This is the example we just did right here. And what do we notice? The looping variable is just a what? You need to know this term for what the looping variable is. The looping variable can be anything at all. It's just a what? Whatever goes right here, which is called variable when you bring up your for loop, the looping variable is just a what? You have to know this. Just a placeholder. Julia, keep those answers coming. It's just a placeholder. And then the vector is what values that placeholder will take on as it runs. And then inside of here, you see the skeleton, which is our code that endlessly repeats. How long does this code go for? Ooh, that's a good theory question. How many times does the code run? How many times does the code run? How many times does the code in a for loop run? Very good theory question. How many times does the code in a for loop run? How many times does the code in a for loop run? The code in the for loop. Parker, perfect answer. The length of the vector. And Matthew, that's exactly it. It'll run for how many elements, a finite number of times for the length of the vector, for the amount of time specified in the vector, for the length of the vector. Exactly, length of the vector was the exact answer I had in my head. So how long the vector is, it'll run for each element of the vector. So it all depends on the vector. This is just explaining, if you want to read notes, going through here, going in very detail. Now we're going to look at some more examples. I'm going to go to one of my favorite examples, is the Vegas example. So let's go to the Vegas example. These are just tons of examples, but my absolute favorite example is going to Vegas. So let's go here to Vegas and run a for loop, and let's gamble some money. Gamble at your own risk. Let's go to Vegas and try a for loop. Okay, so this is the Vegas for loop example. Going to Vegas right here. What do we notice right here? Explain to me this code. It tells you what it's doing, but explain to me this code in your own words. I mean, you can kind of say like, save into bankroll object numeric value 50. Just tell me like, well, this means we're going to Vegas with what? Just pretend like, what does this mean? What are we doing? Important we know what each line of our code is doing and why we're doing it. I like Vegas. I'm never going to gamble. Good point right there. Good point. Because we've definitely lost some home openers against some easy teams. So we should play that high school team, right? So the one, ESPN one. Stores 50 into variable bankroll. Exactly. We're starting out Vegas with $50. There we go. We're starting Vegas with $50. We now have $50 in our bank. Now, what does this do? Anyone ever play Minecraft? If you've ever played Minecraft, then you know if you load the same seed as someone, the same seed as someone will get you the same result. So this is going to make it so we can reproduce our results. So if you load the same seed, you will get the same result. Doing set seed says, here's the randomness. I like to do this trick. Give me a second. I'm going to read the mind of R. It takes a moment. Okay. So I'm going to tell you a random number between 1 and 10,000. Does everyone see right here? Brian's going to generate a random number between 1 and 10,000 with this code. Totally random. I have a guess. I guess it's going to be 3,362. 3,362. What?
Wow.
Oh my gosh. How did I do that? How did I do that? How did I know that when I would generate a random number, which I am generating a random number, that it'd be, maybe it'll be 3,362 again. Why is that happening? Whenever I generate a random number, I keep getting 3,362. Important to know what set seed does. Why is that happening? What's going on here? Let me generate another random number. Wait, it's not 3,362. What? What's happening? What does this do? Does everyone knows what set seed is doing? Set seed sets the randomness. So if I run set seed, it says, here's the randomness. It controls the randomness. The seed keeps random results while making the same situation 50 points, perfect answer. Exactly. When I was setting the seed, I controlled the randomness so we can get repetitive results, 3,362. So now we've set the seed. If you set the seed to a different number, you will get different random results, but you will always get 8776 if you set the seed and run this. It's for replicating results, Veda, perfect answer right there, exactly. Randomizes are based on long series of numbers, usually pi, and set seed selects what digits it starts on, exactly. And you can go into big details on how these randomness procedures work and how the set seed will control for the randomness. So this is just going to make it so we get the same results every time. Now let's look at what this code does. Let's look at the skeleton first. What is the skeleton in here doing? The skeleton will first start out where bet is set to what? What will bet be set to when the skeleton runs? Well, the first time it runs, bet will have what set into it. We're going to look down here at what it's doing. So what will it have set into it? Be careful. You're really close. Daniel, 20 points. You're really close. It'll have 2. So we're actually starting this one at 2. Daniel's like, update 2. So we're doing this right here. So the first time this runs, it'll have 2 stored into it. Then the next time it runs, it'll have 3 stored into it. And it'll just keep running all the way. When will this loop stop? When will this loop stop? This loop will stop when bet has what stored into it. When will this loop stop? It'll store 2 into bet, it'll store 3 into bet, it'll store 4 into bet, and it'll run all the way until 50 stored into bet, because that's the end of the vector right here. Great job right there, Matthew. 20 points, excellent work. And then it'll run all the way till 50 stored into bet, and that's where it'll stop. Now, if you notice right here, how are we doing this? Well, we're taking right here and storing into outcome a sample right here of what happens. We will either gain $1 or lose $1. We're selecting one of these, and the probability of winning is 18 over 38, which is a little bit smaller than the probability of winning or losing. Wait, winning is a little bit smaller than winning. Winning is a little bit smaller than losing. Here's winning. Here's the probability of winning. Here's losing. Here's the probability of losing. And the probability of winning, which that's winning, is a little smaller than the probability of losing. So every time we do this, it's going to generate whether we win or lose. Does that make sense what you're seeing right here? This is winning or losing. If you see a -1, you lost $1. If you see a +1, finally we get some wins, you've won $1. And all that's going to happen right here is this is going to be stored into outcome for what happened when we made that bet. We what here on this bet? What happened on that bet? What just happened on that bet? What just happened on that bet right there? What happened? We're just understanding what the code does right here. What just happened on that bet? What just happened on this bet? What was the outcome of this bet? We lost $1. I've got a lifetime. Good, awesome. So we lost $1, and that's currently stored into outcome. This is -1 right now, currently. It might not always be, but we lost $1. So we're going to take what our bankroll was, because this is the previous position of our bankroll. When I run this code right here, remember it's what we currently have in the bank. What is this going to evaluate to? If I run this code, which says go to position 2 minus 1, position 1, what are we going to currently get right here if we check bankroll position 2 minus 1? What are we going to get if we look at bankroll position 2 minus 1? Which is what we currently have right now at position 1 in our bankroll. What are we going to get by running this right here? Checking what we have in bankroll position 2 minus 1 is bankroll position 1, which is what we currently have, which is how much money? How much money do we currently have? This is bankroll position 2 minus 1, so it's bankroll position 1. It's just what we currently have in the bank. And so what will this code evaluate to? This right here will tell us that we have exactly $50, Matthew, 50 points right there. Boom. $50. And then all we're doing is taking and putting the outcome on this, and now we have 49, and we're storing this into position 2, and guess what? Our bankroll has now been updated. And then we go and we make our next bet, and we update our bankroll, and guess what? We get we won our $1 back. So outcome currently has a positive $1 in it because we won on that last one. Does this make sense what this is doing? That each time it's going to append to the bankroll vector a new outcome or new bankroll amount, which is the previous bankroll amount, because this time it runs with 4 here. So it's going to take from the third, which is 4 minus 1, store into position 4, whatever the outcome was, and we can see that we lost our $1 again. So outcome was -1. So it's updating it each time by going to the previous amount we had and adding the outcome to it. So this is going to show us what happens as we go repetitive amounts right here. So with this right here, what happens if we stay in Vegas all semester? This is much longer. We're only at $1 table. We'll stay there all semester. And you know what? I'm going to make your odds a little bit better. I'm going to put your probability of winning, I'm going to put your probability of losing at this right here. And your probability of winning at, or probability of losing, excuse me, I'm getting the reverse. This is the probability of winning, because it's the first one, and this is the probability of losing right here. Those are probabilities for those. What do you think would happen if you stayed at Vegas all semester? Better be careful. All semester is 50,000 bets. What do you think would happen right here if you stayed at Vegas all semester? And you're pretty good at this. You're pretty good. You've got a 49.7% chance of winning. Oh God, this is gonna be bad if it turns out good, it'll be bad. Bankrupt. You know, you didn't do too poorly, but you're probably not that good of a player. You probably win about 40% of the time at Vegas. So you probably win about 40% of the time. And if we redo the odds right here, now when we redo the odds, oh, did I not rerun the code? Now when we redo the odds, oh, we could look at the very end of the bankroll right here to find out what happened at the end. Running tail is going to tell us the end of the story. You're $1,000 in debt. And that's not saying you should lose $1,000, but if you spend all semester, well, you're still having to like lodge yourself and buy food, but you're just losing money continuously, which is probably the way Vegas goes. You know, it'd be interesting to look at your first 100 bets right here. And the first 100 bets, you started winning actually a little bit at the start. Your first 20 bets, ooh, look at this. At the start, you were winning a little bit. At the start, someone was winning and they thought they were doing great. And yeah, they were not doing great. They ended up losing. If we go further out in the series, you can see what happens and you are just continuously losing. And it's really neat when you take a look at these because you'll see different patterns that can easily occur. And we should get, oh, we're doing the set seed. Let's remove the set seed so we do get random patterns now. And you could see somebody, even with these odds, will anyone ever come out ahead? Wow. It is taking a lot of tries to find someone who comes out ahead. You know what we should do? We should put this right here. That'll get us the last amount. Whoa. It would take a lot of tries to come out ahead. Some people are going negative after 50 bets. You know what? There's a way to do this. And we'll do one more example after this. Can you explain what set seed does again? It sets the randomness. That way, if I were to ask you, let's go here to set seed. I'm going to set seed 1 right here. I'm going to go to sample, heads or tails. This is a coin flip. Call it in the air. Call it in the air. Is it heads or tails? Is it heads or tails? Is the coin heads or tails? Call it in the air. Call the coin in the air. Is it heads or tails? Call it in the air. Is it heads or tails? Call it in the air. Is it heads or tails? Tails. You're wrong. Call it in the air, heads or tails. Call it in the air, heads or tails. Tails always fails. Why is tails always failing? I'm cheating. Why is tails always failing? Why is tails? You're like, Brian, what? Every time you run this, I can make it easier to run if I do this. Why is tails always failing? Wow, tails is never coming up. I've set the randomness. I am controlling the randomness procedure. That way we always get the same randomized result. It is random, but it's controlled, which you'd say, well, that's not random then? Well, it's random, but I'm just saying do the same randomness, which is still random. It's weird. How about this, though? And I like this because this is where we can get really advanced. Do you see this tail of bankroll right here? This tail of bankroll is currently stored, but watch this. I'm going to run this, and I think the plot will run. While tail of bankroll right here is less than 50, run this code. This might take a moment. It finally happened. We could even do it to see how many tries it took by putting a counter in here. Let's go here to I, set I to 0. And I guess, yeah, and then we'll go over here, I plus 1. So we'll go right here and go to I, save into I plus 1. And that'll be a counter for us. So now we can do this again. Wait, oh, because we currently have that stored right here. Let me run the code right here so it doesn't have that in its brain anymore. And let's run this. Now we've changed it, so the bankroll should be different. Oh, cancel, cancel, cancel. Okay, we're good. We're back to broken. I mean, where we didn't do it. So now I'm doing the same code right here, and I'm running while we have not won money at Vegas. And to answer the question of how many attempts did it take for somebody actually to win money at Vegas, it took only 638. I'm actually shocked. Only 638 attempts with these odds to win. So that's when someone comes back from Vegas and they actually, here's their real odds of losing. And if we were to change these to worse odds, it would take more attempts. But we did this by throwing it inside of a while loop, and this code continuously ran. I want to ask a quick question. On a scale of 1 to 10, how much do you understand the Vegas example? Please answer honestly. On a scale of 1 to 10, when we just did the Vegas example with having the for loop run, on a scale of 1 to 10, how well did you understand the Vegas example? 1's like, I have no idea what's going on. 10 means great understanding. Parker, thank you so much. Parker, I think you've got a lot of 3. It's going to take some practice. Don't worry. That's where we practice. Parker, how long have you been coding for loops? 5 is good. 5 is good. 4, we got this. 4 is good also. 1 scares me. Would tell me if it won, if so. 7.5. And I think Parker, high school. That's why. If someone says 10, I'm like, how long have you been coding these? Who understood the while loop right here, which we didn't cover today, which won't be on your assignments? Who understood the while loop right here? Well, I put a condition in here. It's going to check the tail, and it's going to find the last value and look at if that's less than 50, but only a handful of computer science classes. Yep. It takes practice to understand this. It takes practice. Let's do one more example right here from the notes, and we will be covering this more on Monday. We'll be covering this more. So now we have the moving average example. Let's go here and grab the moving average code. We have just enough time to talk through it. And let's go grab it. With the moving average right here, what do you notice we're doing? What are we doing again at the very start of this? We are setting the what at the very start of this. So anytime you see set seed, you're just controlling for the whatness. What are you controlling when you see set seed at the start of this? You are controlling the whatness. So that way, when I run this right here and I look at demands, every time it's the same. So we've just appended these 2 lines of code. This connects 2 lines of code to 1. It would literally be the same thing as having these codes like this and running it like this. It's going to get me the same result right there. We get the same randomness. What does this do right here? It uses the repeat function to repeat the following 50 times, and we're storing that into moving average. So this has created a blank vector of sorts, a vector of emptiness, missingness, of NAs. So it's important we know NA is missingness. We're repeating NA 50 times and storing that into an object right there. Now, what is the name of the variable in the for loop? Good review questions. What is the name of the variable in the for loop? What is the name of the variable in the for loop? What is the name of the variable in the for loop? Good review questions in class right here. What is the name of the variable in this for loop? Time. Time is the name of the variable. So anytime you see time, when this loop runs, time will become the first object or the first element of the vector. The first time this loop runs, I'm throwing 100 points. People are paying attention at the end. Stay till the end, start on time, leave on time. So time, the first time this loop runs, will become what? The first time this loop runs, time will become what? The first time this loop runs, time will become what? The first time this loop runs, time will become what? It'll become the first element of the vector. The first time this loop runs, time will become what? It'll become 3, and then the skeleton will run. Hints for your assignments. The next time the loop runs, time will become 4, and then the skeleton will run. And this process will repeat until time has saved into it 48, and then the skeleton runs. We could do this all by hand, or the loop could just do it for us. Now, you might be wondering, why didn't we start at time 1 or 2? The thing is, when we go to demand, our moving window right here is going to time -2. So I'm put 1 minute on the clock, 1 minute timer on the clock initiated. If we were to go to time 1 in demand, when we go to time -2, what position would we be at from if we start at 1, if our loop started at 1 and we went to time -2, we'd be at position what in demand? So if we were at time 1, if we started the loop at 1 and we went to -2, we'd be at position what, which we can't really do. And there's no position -1. So that's why we start at time 3. And when we start at time 3, we create a moving window of these numbers. And that's why this number right here is an average of this moving window. It's also why at the end we stop at time 48, because time 48 creates a moving window of these numbers because we can't go to time 49 because we can't go plus 2 on 49 and we can't go plus 2 on 50. And that is the end of class. Really good practice right here. I can't state this enough that you have to practice. It's practice makes perfect. You're not going to learn it like in one day. It's going to take practice. And I just want to say, great job. Let me throw out another 100 points. This is the hardest parts of coding you're going to have. And a lot of people get really scared right now. But you know what? This class is like biking uphill. What do you have to look forward to when you bike uphill? And I promise you, I'll have someone who's taken this class telling the next group of students about this. What do you have to look forward to when you bike uphill? The view. Oh, that's awesome. I love that a lot. That's another 20 points right there. You got the view. And then you got the downhill. This will get easier. Yeah, we're on that steepest part of the hill right now. This is where you're like standing up and you're like, you're pushing down on the pedals. This is the part where we're just like pushing through. This is probably one of the hardest parts of the class right now. These first few assignments, not that we're trying to do like, oh, the hardest assignments are first. No worry, Daniel, you're doing great. Just start one of the homework questions. Here's what I want people to do. If today was super tough, and Daniel, I'm throwing 50 points, Daniel, for saying the super tough today. I appreciate that. I want you to go to Discord and I want you to say, I'm stuck on this part of this question. I can't get my for loop to work for this. Ask me, ask someone else, be helping people. Maybe I'll even do something where maybe we can get a little more Discord bonus. No, I made an agreement. You can get up to a half a point on your grade by chatting on Discord. So once again, you can get a half a point on your grade by chatting on Discord. If you haven't started chatting on Discord, jump in, start chatting on the BAS 320 channels. Our TAs have been pretty responsive. Nana Bryan, who's awesome, great teacher, is also on there answering. Who's had a question answered by Nana Bryan, who's absolutely amazing. A lot of times during the day, I'm answering a lot of emails. I'm teaching, so I'm usually on there more towards the evening after I eat some dinner and have a moment, go play some Pokemon for a half moment. Who's had a question answered by Nana Bryan? Because she's doing an amazing. I'm so happy that she's answering questions on Discord, because I'm just like, yes, everyone can go to the Discord. Everyone's gonna see answers to help out, to communicate. So big shout outs to Nana Bryan right there. Great help, and I think it's really helping facilitating learning. Nana is the best. I really appreciate I'm so happy with the utilization right there, because then you can just get help. You can just be like, and she's on there helping out, answering questions. Oh, it's just Brian Stevens. Don't worry. And I don't have my PhD yet, which I need to look into that. Is that on my board? Contact PhD people. And I paid the rent today. Always pay your rent. So I need to start my I've done some PhD work. Hopefully those hours count. You're welcome. It's that people are succeeding. And if you miss the first assignment, which does apply to a few people, don't worry, there are drops. My hair's just gonna look all crazy. Go Vols tonight. So if you miss this first assignment, you're not failed. Don't worry. The class will get easier. Image file. What? Is this one? What? Whew. I'm gonna go grab a little more food. Excellent work, everybody. Great class today. We'll be back. We're going to do some office hours here in a moment. We'll be back. Please keep asking questions. Just let me know whenever you have a problem. I just want to help out, and you're doing great. You're working hard. You got this, everybody. Go Vols tonight. We're going to win. I'm going to go grab some more food and be back. Bye, everybody. Bye. Awesome. Yeah. Watch the game tonight. I'm still on my mic.